Hello everyone, I am excited to introduce our capstone project, which is prediction of wind speed using machine learning models. Abstract of our project is to predict accuracy of wind speed, which is essential for optimizing renewable energy systems. Here we are using machine learning models such as CNN, LSTM, GRU, which can predict accuracy of the wind speed by leveraging historical meteorological data. These models aim to improve prediction accuracy and address temporal and spatial variability for wind speed forecasting. The primary objective of our project is to develop robust and accurate forecasting techniques and to develop models capable of providing accurate forecast for both short term and long term time frames, catering to diverse operational needs and understanding wind patterns and their changes over time to contribute climate research, and also to improve the accuracy of wind speed forecast by developing advanced machine learning algorithms. Introduction of our project is to the primary purpose of predicting wind speed is to address a range of real world challenges and application across various industries. Wind speed prediction is essential for optimizing wind energy production, as wind turbines rely on accurate forecast to maximize efficiency. Traditionally, physical models based on meteorological data were used for this purpose, but machine learning models offer an alternative approach that can handle large complex data sets and uncover patterns in wind behavior and more effectively.
This is the literature survey of this project. The parameters includes are author, year, title, methodology, key findings and limitations. Existing system of the project is machine learning models that are artificial neural networks, random forest, support vector regression and gradient boost.
The disadvantages are over-reliance on historical data, poor handling of nonlinear relationships, and limited generalizability, high computational complexity, and inability to capture complex patterns. Moving on, the existing methodology for this process is regression models. We have two types. Those are linear regression, which is simple but limited, and SVR, which means handles non-linear relationships. So we have both for linear one and non-linear one. And the other existing methodology is tree-based models. So there are two types of tree-based models. They are random forest and gradient boosting. We use random forest for robust and interpredictable ones, and gradient boosting those for high accuracy, like we need the correct input or for correct output ones. Example are XGBoost. And the third one is hybrid models, which combines both ML with physical models for accuracy. Moving on. Problem identification. Problem, how to identify the problem. Wind speed prediction is challenging because it is dependent on non-linear relationships and dependence on various factors like atmospheric pressure and humidity. So with these, we take atmospheric pressure, temperature, and humidity as the main problem. For this, we take those as the factors. Data related issues. The data related issues can be quality and accuracy of weather data. Example, we use sensor calibration, missing values. Limited historical data or inconsistent data frequency, and integration of diverse data sources, example weather stations and satellite imagery. Handling nonlinear relationships between variables. Modeling challenges are selection of relevant features, example temperature, pressure, humidity. Accounting for spatial and temporal correlations. Handling non-stationary and seasonability. Choosing optimal model complexity. Avoiding over or overfitting in the optimal model complexity. Thanks.
The challenges we face during wind speed prediction. Wind is not a smooth flow. It's characterized by fluctuations in speed and direction. These fluctuations, known as turbulence, are caused by various factors like atmospheric instability, obstacles in wind path. The wind speed doesn't follow a steady pattern is known as intermittent behavior. It can vary significantly over short period. Even the shape of the land, including hills, valleys, and mountains, can have a significant impact on wind speed and direction, known as local topography and terrain effect. The type of surface also influences wind patterns. Urban areas with tall buildings create wind tunnels, while rougher surface like forest can slow down the wind. The weather patterns such as thunderstorms can generate extremely high speeds. Overall, these factors make wind speed prediction a complex task. Accurate predictions require sophisticated models that account for all these variables and their interactions. The potential machine learning models are time series forecasting, gated recurrent unit GRU, the encoder decoder LSTM. The proposed methodology starts from the data preprocessing, feature extraction, training, validation, testing, and evaluation. Implementation starts with the data collection. The real-time wind speed data from the meteorological stations are collected. And the pre-processing starts with the data cleaning. It removes invalid values like negative for the wind velocities, assuming they are invalid. Missing data handling is done by the interpolation. The code identifies rows with missing data, fills the missing data using interpolation by calculating mean of the column. And the normalization is a data preprocessing technique used to scale data values into a specific range, making it easier for a machine learning models to converge and perform better.
Feature selection of the project is recursive feature elimination. It is a feature selection method that recursively removes the least important features based on a model's performance. Model development. Select a variety of machine learning algorithms for comparison, including linear regression, long short memory, data recurrent unit, encoder, decoder. Evaluation is evaluate and compare the performance of various models using validation matrices to identify the best performing one and conduct error analysis to investigate the types of efforts made, highlighting areas for improvement. Deployment. Implement a real-time wind speed prediction systems that integrates the selected model with live data feeds accompanied by a user-friendly interface for stakeholders to access predictions. Results of this project is improved accuracy through feature engineering and enhancing handling of nonlinear relationships, better generalizability across locations, reduced computational complexity, and real-time adaptability. In conclusion, predicting wind speed using advanced machine learning models presents a transformative approach to tackling the complexities of wind behavior and its significant implications across various industries. The integration of sophisticated techniques like the stacked GRU enables more accurate and reliable forecasts by leveraging large datasets to capture, integrate nonlinear relationships and dynamic patterns influenced by multiple meteorological factors. By effectively modeling and predicting wind speed, these advanced models support better planning and utilization of wind resources, contributing to the efficiency and reliability of renewable energy systems.